Hello everyone, welcome to DCC YouTube channel. Now we are going to discuss the third problem of today's biweekly contest, that is minimum length of array using operations. You are given a zero indexed integer array nums containing positive integers, and your task is to minimize the length of nums by performing the following operations any number of times. So the operations include select two indices I and j from nums and such that nums of I is greater than 0 and nums of j is greater than 0. And we need to insert the result of nums of I percentage nums of j at the end of nums and then delete the elements at the indices I and j from nums. So we need to return the minimum length of nums after performing the operations any number of times. So our ultimate goal is to minimize the length of array by using this operation. So let's look into the example. The array is given 1431 and we need to minimize the length. That means we need to reduce the array. So in operation 1, we can select indices 2 and 1. That is, we can select these two elements and then the mod of these two elements would be 3. So we insert 3 at the end. That is, then the array becomes like this, and then we delete 4 and 3. So that becomes 1, 1 and 3. So similarly, if we continue the process, that is for 1 and 3, then that would result in 1 comma 1. So if we observe, we are just popping out the maximum element out of both of these. If we do nums of I percentage nums of j, and since the last two elements are 1 comma 1, the mod of 1 percentage 1 is 0, and we would be left with 0, which is the minimum answer in this case. So similarly, this is also an example. So let's look into the other example. Yeah, so if this is the test case given for us, we can check if 1, 1, 1, 3, 4, 5, 7, 2, 2, 2. If this is the test case, the simple observation here is that if we pick a minimum element and a greater element, and if we do 1 percentage 3, then obviously the maximum element is popping out in this operation. So then we pick 1 and 4. So 4 would be popped out, and 1 and 5, 5 would be popped out, and 1 and 7, 1 and 2. Similarly, like just for one minimum element, we can pop out all of these other elements by using this operation. So then we would be left with 1, 1, 1, and then modulo of these two numbers would be 0, and this number will be left like this. And since we can't choose nums of I as 0, this would be the final array, and the length of this is 2. So the answer for this test case is 2. So if we observe, the answer is just depending on the frequency of the minimum element. So first we calculate the frequency of the minimum element, and like if the frequency is even, that is like if there are 6 ones, then this would become 0, and then this would become 0, and then these two would become 0. So the answer would be frequency by 2. And if it is odd, like we have seen in this case, the all frequency by 2 numbers will be zeros, and the last one would be 1. So the answer, if in the odd case, would be this. So this is the answer. But if we there is an edge case for this strategy, because for example, if we take this example, like all 2s, 4s and 5, 5, 6, 6. Okay, so if we apply this strategy, then the frequency of 2s is 4, and then ultimately the array would be 2. So array size would be 2. But if we observe, 5 is also there in this array, and 2 is also there in this array. Like till now, we are just taking the mod of 2 percentage 5, that is resulting us in 2. But if we take 5 percentage 2, then that would lead us to another element, that is which is less than this minimum element. Okay, so then in that case we would insert 1 and then pop this 2 and 5. So we have discovered a new minimum element, and since we have discovered this new minimum element, obviously the frequency would be 1 in this case. So ultimately, we just want the frequency of the minimum element to be very least. So then we can pick these elements, all other elements, and we can just eliminate this whole array using those twos. Sorry, using those one, this single one. So so the answer in this case would be just 1, because the last size of the size of the array left in this case is 1. So not only checking the frequency of the minimum element, but also we need to iterate through all the unique elements of the array and check whether if it is if we like nums of j percentage nums of I, if it is less than the 2, like in this case it is 1, right? So which is less than 2. So if we encounter such a minimum element which is less than this, then we simply return 1. Otherwise we would just go with this formula. So let's look into the code of this solution. Yeah, so I'm just maintaining a map to store the frequencies and the unique elements, and then I'm storing the minimum element and also the frequency of the minimum element. And if the frequency is equal to 1, then we just simply return 1. Otherwise we iterate through the map and check whether if we do this operation and if it is not equal to 0, and we should also make sure that it is not equal to 0, because nums of I and nums of j should not be equal to 0 as per the question. And if still if we if this operation by making this operation, if we encounter any other minimum element, then we simply return 1 as we have seen in that case. And if we did not encounter any of that element, then we would just, if it is even, then we return frequency by 2, else return frequency by 2 plus 1. And that is it. Thank you.